Okay, what we're going to do now is a fair amount of your homework. So you should have page 1 with you right now. If you don't, you need to look on my website for Monday, where I will have a link for page 1, and that link will also give you page 2, which we're going to do right after this. So we're going to start up here with that first number 1 thing, and can anybody tell me what that reaction is most likely going to be? Anyone? Double replacement, all over the place. This is definitely double replacement. It's what we did in our lab 90% of the time. Okay? So, there's your double replacement. And number 2, what do we have? Single replacement. Single replacement is always going to be what else? Oxred, changes of charges. Look at that calcium. What's his charge? Come on. What's his charge?
0.
0. Good. What's his charge over here? 2 plus. Now you look up on the chart. You see he's in column 2, and you know he's got to be a 2 plus. Okay, he's one of the representative elements. And how about hydrogen? What is he over here?
0.
No?
Oh, it's 1. It's 1.
Yeah, he's a 1 plus and chlorine's a 1 minus. And what is hydrogen over here? Huh?
0.
0, because he's all alone. Yes. So he's not only single replacement, he's also charges change in what reaction? What reaction? Come on. Octret. Sure. Octret. All right. How we doing? We starting to make some sense? I know you're having to take in a lot of stuff at one time, but if you've taken good notes, you should be okay. Just look down your different reaction types and see what makes sense. This is 2 things becoming 1. What might that be? Well, it is combustion, but not because 2 become 1. What is it? Well, what makes it oxygen where? On the left. O2 oxygen. Okay, O2 oxygen right here, all by himself. That makes it combustion. And what else is it? It is oxred. It's something else. Also, why is it oxred? Charges change. Let's charge potassium on the left. Good. Potassium on the right. 1. Good. Let's charge on oxygen on the left. What is he on the right? Well, you guys aren't missing on that oxygen, are you? No. Oxygen. He's in column 5, or column 6. Column 6 is what? 2 plus, 2 minus. 2 minus. Yeah, 2 minus. Okay, so both of these are changing charges as they come together. So we got synthesis, oxred, and what's the last one? Changes in charge, oxred. Oh, we got them. Okay. Oxred and combustion. Okay, let's do this guy. Come on, we've seen this one before. What is he?
Oh, isn't this double replacement?
No, it's not double. Single. Single replacement. Double replacement, you don't ever see elements. Okay, the Cl2 is element, chlorine. Er2. So you have elements on both sides. That tells you right away that you have oxred. If you see an element on one side and he's together with something else on the other side, you got oxred. You don't even need to think about it. That is oxred. Definitely. And it is definitely a single replacement. Okay. How about 11? What do we have there? 1 becomes 2. What is it? What is it?
The composition.
It is decomposition. Now remember, decomposition can sometimes be ox-red. Is it this time? Do we have an element anywhere? Nope. So, just decomposition. Remember I said decomposition is sometimes ox-red. In this case, it's not. You have to have an element for it to be a ox-red. All right, let's go on to page 2. I want to do a couple of these, and that's going to be it for the video. So, here we go. What's the lithium hydroxide and H2SO4? What do we have?
Double replacement.
We do. We have a double replacement. Well, we have something else going on.
Oxide.
No ox-red. You don't see any elements. There's no elements. Okay? So, what else could we make out of this? I'm going to underline some. See if this makes any sense to you. What is that?
Hydroxide.
Hydroxide. What is this?
Hydrogen.
Okay, this guy is base. The lithium hydroxide is a base because he has hydroxide at the end of the molecule. Hydrogen is at the beginning of the molecule. That makes it an acid. What kind of reaction could that be? Acid base. All over the place. Oh, acid base all over the place. Oh, yes. Oh, yes. Acid. Ah, yes. I could rap. And so, we look on the other side, and what do we have? We have a salt, any metal with any nonmetal, or combinations, like the sulfate, of nonmetals. That is the pure definition of a salt, metal and a nonmetal. And water. Those are the products of an acid-base reaction. Let's go back here. See it? Acid plus base make water and salt. And the order here doesn't matter, so it could be salt and water like in the reaction we're looking at. Okay? And your background on acid-base stuff is all right there. It's pretty simple. There's not a lot of background to do on that for you. Okay, last one. And then we're going to call it a day. C6H6 plus O2. Remember this guy? What a stinker he was to balance? Wow, he's a tough one. And so let's see what kind of reaction he is. What could he be? What's the one that sticks out like a sore thumb? Combustion. Yeah, that oxygen there. That tells you something right away. So we have combustion. If we have combustion, what do we always have that goes with it? Ox-red. Do we have an element on either side? Is there an element on either side? Look again. O2. O2. No, it doesn't have to be on two sides. Either side. It have an element, and especially if there's an element on one side, and you see them, in this case, oxygen is in part of CO2, and he's part of water. Okay? So, obviously, his charge has changed. So I hope you find this helpful, and we'll get you a good start on your homework, and you'll be able to do everything from here without my lengthy explanations. You should be able to go really fast. Thank you for watching.